Okay, let's get this show on the road. Hello, everyone. Hope you're well. Welcome to another edition of Math 1000. Hopefully you guys are doing well. So let's share my screen here. I'll make sure that I can see the chat. So we have a couple of important activities to do today. Of course, the main one is going over the quiz that I gave you guys earlier this week. But we have some other things to take care of. And I need everyone here to be able to do that. And I think I have pretty much everyone here, maybe missing one person or two people at most. I don't remember, but it's probably one or two people missing. I think that's enough to actually get everything done. Last time I did the activity towards the end of my class and a couple of people left early or just left their computer. So I've decided that I'm going to do it at the beginning of all the other classes. So we'll actually do that before we get into the quiz material. So shouldn't take long, like 5 minutes. So I think by like 10 or 15 minutes in, everything should be wrapped up and then we can kind of rush through the quiz, which I think was a shorter quiz. So that probably shouldn't be too much. So before, and again, I encourage you to have your cameras on, especially today, because you'll be meeting a lot of new people and it's nice to just have a face to greet instead of just a username. So let's just actually talk about some announcements or the agenda that I want to go over for today. And just to make sure that you guys all have kind of things in mind. Of course, I can only tell you about what's going on in this class and about general information like finals week, but I don't know what classes the rest of you are taking, so I can't give you any general structure for that. But just to give you some sort of structure the best I can, based on what I know, please be aware of the following awareness. So first of all, fill out the doodle polls for tomorrow's session. So by tonight at 8 p.m., I'm definitely going to choose a time for when that's going to be. So please, if you haven't done that already, do it today, right after class. Quiz 6 is on Monday, November 30th. So that's after Thanksgiving. You have the next quiz. And the test 2 is going to be a few days after that on December 3rd. So just if you're like mapping out when the big exam type things are coming up in this class, those are the next two things. After that, we have the final. So the final is on December 14th at 9:30 a.m. Again, this is from the official Fordham final exam schedule website. However, these things are always kind of tentative, especially with what's going on now. I don't know if a lot of you know, but some schools are closing down again due to the current situation. So I don't know what's going to happen in December, but for now, December 14th, 9:30 a.m. is when your final is supposed to take place. And of course, the closer we get there, the more information I'll be giving you about it. So after test 2, we'd have one more Zoom meeting to get through. So that's on Monday, December 7th. I think the last class, that's probably actually the last class. I think the last class is around the 8th or the 9th or something like that. So that's probably the last time I'll actually see you guys officially. Okay. As well as for the above, so you guys probably saw that I added you to a forum type thing called Piazza. You might have gotten the email about it. If not, you can let me know. But at this point, especially for the benefit of all and just to make things a lot more efficient, I would highly recommend that if you have questions about the class or questions about specific problems, that you actually ask them on Piazza. And the reason is, one, I don't have to answer the same question for multiple people. And sometimes the answers to certain questions are valuable, even if students didn't even know that they should have asked that. So sometimes when someone asks me a question in an email and I would just answer that one person in an email, I think a lot more people in the class would benefit from such an answer. So I think making answers, questions and answers public would be a good idea. You can do this anonymously, so it's not, you don't have to identify yourself when you're asking a question or anything like that. You can just ask a general question about the class, about a problem you're working on, about a study strategy, about whatever. And I will be able to answer so that everyone can see my answer. So I answer one time and everyone sees it immediately, as well as other students from the class would also be able to chip in and answer their question, which, you know, it's good for coming together as a community, helping each other out, as well as there might be times when I'm away from the computer for a long time and you want to get some answer, and you might have a classmate who's online at the same time who knows the answer and they can help you out. And I would be able to endorse answers from students. So if a student told you the right thing, I'd be able to say, yeah, you're good. Or if a student told you the wrong thing, I'll be able to instruct both of you on why that's the wrong thing, and maybe expand on answers and things of that sort. So I think that'll be very good. And as anyone who's ever been a tutor or a teacher can tell you, one of the best ways to learn is to actually teach someone else something. So if you know something, it's still to your benefit to actually help someone else out. Because by you explaining to another mind how to understand something as well as you understand it, you're going to have to deconstruct ideas in a way that makes them more comfortable to you, and you're going to be able to master the material better. So whether you're asking questions or answering, I think answering or asking in that capacity will be very helpful to the community, very helpful to the class. Get some more interaction going. You guys seem very shy or whatever, but you need to get out of your shells and start collaborating, I think. Which leads us to one of the main activities of today. I am going to be putting you guys into groups. So I've dissected the class into little groups, little study groups, little tribes. Basically, you guys are going to be put into a group of, I think it's roughly 4 people each group. There might be a group of 3 people or whatever, but it's average. I think there are 4 people per group. But it's really just your study group. So I'm going to be putting you guys in groups. And the idea is just to have a hub for you to go back to when it comes to this class. I think it would be very good if you guys schedule some regular meetings, study meetups, and you guys can work over Zoom on problems together, pitch ideas and so forth, and just help each other out. And just to have, you know, the feeling that you're not alone and you're actually working with people. And they might have some strategies and tips to give you. And you might find that you have even more classes in common with some of your other students that you didn't even know. And you guys can study for multiple classes together. You never know. But it's hard in the online way of doing things to actually create these little groups and cliques that can be very useful academically. So I'm going to, I decide to manually create them myself. So what we're going to do is I'm going to have you right now meet your group members. And so the point of the meeting now is not to discuss everything, right? So it's just going to be a very short meeting, 5 minutes or less. And this is the point. One, in that meeting, you're going to exchange contact information. So everyone should have everyone else's email or whatever you want to give for contact purposes. And 2, you should designate sort of a point person for that group so that if someone is absent today and they didn't make it into your group meeting, I will be able to say to that person, oh, if you're in group number 3, reach out to this person and they'll catch you up on what was discussed. As well as if you as a group have something, you can just have one person reach out to me instead of me having to talk to 5 different people. I know I can talk to one person and then they'll disseminate that information among the group. So just kind of like a, I don't want to say a group leader, but just like a liaison, a point of contact with the group. So you're going to choose that person. So you're going to exchange contact information and choose the point person. So those are the 2 main things. Now, if you do that very quickly and you have time, sure, you guys can introduce yourselves, you can talk a little bit, whatever. Maybe even take the time to set up a group chat. In the class that I did, this was yesterday, a lot of them already, by the time the exercise was done, they already had a WhatsApp group chat set up and they're like, yeah, we're all already talking. So it's like, so that's doable as well. And yeah, so at some point afterwards, you guys should meet up, come up with a schedule together, come up with a plan together, help each other out, that sort of thing. And yeah, but the main things for right now is to exchange contact information, pick a point person. So what we're going to do, how we're going to manage that is I am going to put you guys into something called breakout rooms. So what that would be, you should make sure you can see the entire Zoom window. So if you're in full screen mode where you can only see my OneNote thing taking up the whole screen, you probably have to exit out of full screen mode, but make sure you have the entire Zoom app, you can see the entire window, because it's going to be either to the bottom or to the top, wherever your control panel is, where you'd see the mute button, the stop video button, all that stuff. Down there, you're going to see something called breakout rooms. I think the icon is just like 4 tiles, and you should be able to click on it and select a group. So right now, you should be able to see it right now. Now, some people, and if you can see the breakout room right now at the bottom of the screen, I would suggest you just you click on your room and you can go and just hang out there until the rest of your group gets in there. Some people I noticed couldn't see where the breakout rooms, or they didn't know where to look. So I can manually put you in a room if you identify yourself. But for now, look for the breakout rooms at the bottom. And does anyone see it? Well, this is strange.
Yeah, I think that's just for you. I think you manually have to give us a notification to click it.
I already did.
Yeah, I don't see it on mine.
Okay. Because I did set it so that you guys could do it yourselves. Let me make sure that that was how it's set up. Yeah, I did set it for you guys to be able to see it. So I don't know what's not working. I guess we will go to doing the, I'll manually put you guys in the room then. So it'll take a little bit more time, but not that much more time. So what I'll probably do is ask you guys, I'll call out the names and then you'll just tell me what group you're in. You should already have an email from yesterday telling you what group you're in. So I can call out the names, you tell me what group you're in, and I will manually put you in the room. And yeah, and once I put in the last person, I'll give you guys about 5 minutes to do all that. So I don't know. I did this yesterday. Some people could see it, some people couldn't. I don't know. But I'm pretty sure I had the right setting. So what I'm going to do now is I will manually put you guys in. And since I will be calling out names, let me stop the recording so that I can protect your privacy. And then when everyone comes back to the main group and I want to start class, I'll start the recording again. If someone doesn't see the recording button when I start class, please remind me so that I don't forget to hit record. But right now I'm going to stop so that I can put you guys in groups, and then we will move forward. And we're back. Okay, so hopefully you guys enjoyed that. I visited some rooms. A few of you still seem a little bit shy. No one had cameras on or anything, but hopefully you guys actually spoke to each other and actually set something up. So as I mentioned, hopefully you got everyone's contact information. If anyone was absent from your group, make sure the point person reaches out to me. Just shoot me an email and be like, oh, this person was supposed to be in our group, but they didn't show up. And yeah, other than that, hopefully you had a little bit, a few seconds. It seems like a team building. At least you could come up with a group name. I suggested the Mighty Ducks to a bunch of groups. They were group 2, the Mighty Ducks, or Students Alliance Against Jhevon's Tyranny, or Go Rams, yeah, whatever. You guys, but really, I do want you to guys have like a sense of community, a sense of belonging to a group, a sense of that, we're not alone, we're all fighting together. It's kind of hard to get that feeling in an online setting, but it's important, especially for a lot of people. And I think you would benefit from being able to bounce ideas off someone who's kind of going through the same thing you are. So user group, I recommend, as I mentioned, setting up regular times for you guys to meet together, study together, whatever. And that's actually something that there was a strategy, and I'll talk about this tomorrow, where it sounds interesting and it sounds like it could work. I'm actually thinking of trying it, and I can try it with you guys, because that's kind of the whole point, to kind of get everyone in a working mode. Because sometimes when you're by yourself at home and you don't want to just sit down and read books because there's so many other things to do. But one of the strategies I'm going to be talking about has to do with work calls. And it's like, it's easier to pay attention when you're in an environment where literally everyone is paying attention to something. It's kind of like how, if you're at the library and everyone around you is reading a book, you kind of feel out of place if you're not reading a book, kind of thing. So as opposed to if you're at home, sure, you'll have books, but you also have Netflix. You also have the possibility to go outside and walk around. It's easier when there's a group of you focusing on the same goal. And I think that's useful. And I think I might even get myself involved in that as well. So we can all just have these work calls. I'll talk about that strategy later on. And if I want to try it, which I do, I think I'm leaning towards doing it, I'll get you guys all involved as well, so you guys can be studying along with me, because I'll have my own final exams to be doing this semester, it turns out. So we will talk about that at some point later, and I'll talk a little bit about that strategy tomorrow as well. So make sure you fill out the doodle poll and to get that. That being said, let's go into the other main activity of today's class, which is to actually get through the quiz. And hopefully we have enough time to do that now. Okay. So probably going to be moving a little faster than usual, just to make sure we kind of cram everything in here. But still, if you're not sure about something, you can stop me and ask a question, and we will be able to, I'll probably be able to quickly answer it. Okay, so yeah, I mean, we've all been here before. We know the process, so let's get into it. And again, I highly recommend, and this is something, again, I'll talk about tomorrow again in strategy, that don't sit there and be quiet. Don't be afraid to ask a question that you might think is silly. If you don't get something, point it out to me. Just say something, and we will deal with it. Okay, without further ado, because at this point we have about 35 minutes left. Oof. Let's jump into it. So this is quiz 5. This is problem 1. It's not listed here, but that is what it is, Q1. Okay, the graph of a parent function is given. Which of the following is the graph of this guy? So that is the question. This is just testing your knowledge of transformations. What you should recognize that this means is shift 1 unit right, and shift this part is shift 3 units down. And so how you'd kind of figure that out is you'd pick a random point on the picture and see where it should end up. So for example, let's say I pick this sharp corner here. It's easy to identify where its current location is. If I move 1 unit right and then 3 units down, that guy should end up here. And similarly, this guy, you can pick 2 points just to be safe. Picking 1 point is usually enough, but if you want to pick 2 points, that's fine. Especially if there was a scaling factor, I would pick several points. But if it's only shifts going on, it's okay to actually pick 1 point. This one again would be 1 unit across, 1, 2, 3 units down. So you kind of know that there should be like some sort of thing like here. So that part of the graph should move there. So pretty much I'm going to look for something hitting the point -2, -4. So moving down, not that. Hey, look at that. That guy seems to fit. Yeah, obviously not that. Obviously not that. And yeah. Otherwise, everything fits. So it was that third option. Moving down. Suppose f of x equals 1 over x plus 3. Which of the following gives the formula for its inverse? So we saw this, we actually went over this in the review, the practice for the quiz last time. And I do want to say again, I know I emphasized this to one of the classes, but I don't remember which class. So just in case, I'll say it now to both of my classes today. Usually when I have those Q&A sessions where I'm like, oh, let's prepare for a quiz, it is driven for the most part. If no one asks a question, I'll kind of go over some general concepts that I think are important. However, I do take priority to follow where the class wants me to go. So if someone has a question, I will address that question specifically. And so what will happen with these Q&A sessions that I have is that between two classes, they can have very different Q&A sessions. And this was the case actually last week. So last Thursday, the Q&A session I had for this class and the Q&A session I had for the other section were actually different because students brought up different questions. And so I do recommend that if you have time, it will be very beneficial for you to actually watch the videos I post for the other section as well. So this is section RO3. I also have a pre-calculus section RO4. It might be worth your time to actually just look at the video I post for the RO4 class, look at the notes, because I might actually cover something different in the Q&A sessions, because sometimes I do based on the questions that the students have. And I think the Q&A session before that was pretty much the same for both classes because no one asked any questions. And so I just went on the same kind of trajectory. But the last one, and I think the third one ago, those Q&A sessions were actually very different between the two classes. So you can actually get a different experience by watching the other video, and you might actually learn something that you didn't even know you needed to learn. Which is, again, why I think the Piazza thing is a very good idea, because it's one of the things that I've forgotten because I haven't been a student for a long time, but I've actually gone back to being a student this semester, is that sometimes you don't even know what question you want to ask. So I'm realizing in class when some people are asking questions, and it's like, either I'm in a situation where I didn't even realize that that was a question that could be asked. That's very interesting. I never thought about it from that angle. Or I'd end up in a situation where someone would ask a question, and on one hand, I would think the answer is obvious, but then I'm actually glad that they asked the question, because when the professor started going over it, he went over it from an angle that I didn't think of. And I would find out that the answer is something like, oh yeah, well, usually this is obvious, but there's this one little sub case over here that could trick you. And then I'm like, wow, I never thought of that case. I'm really glad someone else asked that question. I didn't even know I should have asked that question. And I ended up benefiting a lot from that. So yeah, I do think you guys should ask questions publicly so that I can answer them publicly, so that other students can look and they can see something and they're like, wow, I didn't even know that that question was worth asking. You never know. So one thing in life is that there are things called unknown unknowns, and that is the case that you don't even know what you don't know. And it turns out that sometimes that kind of knowledge is very valuable. So there are times when you would know the things that confuse you and you're like, I know I don't understand this. But there are certain things that you don't understand and you don't even know that you don't understand. So that's why working in a group and collaborating and speaking in class and all that, it's very, very important. I'm not doing it to put you guys on the spot or make you self-conscious or anything like that. There are good reasons why I make these suggestions. And I'm supposed to be moving quickly and I'm going off at a rant, but it's because it's very important. I'm trying to stress the importance of the things I ask you guys to do. And trust me, like when you actually just go out on a limb and actually do the things I'm asking, you're going to realize that things are going to be night and day. You're going to realize that, wow, I didn't realize that I could get so much from a math class. A lot of people just go to math class because they have to, and they just kind of go through the motions. Yeah, it was just a typical math class. Well, it's because you're not participating enough. Anyway, let's actually move on. So we did actually go through this. I think I went through it with this class, but I'm actually not sure because, like I said, the Q&A session from the last class was very different between the two classes. However, I'll go over the strategy here again. So you start with y equals 1 over x plus 3. You switch x and y. Then solve for y. So that is the strategy here for this kind of problem. So this means I'm going to artificially just put the x in the y position. And now I'm going to solve for the y. And I can do this by cross multiplying. To solve for the y, I need to isolate it. So I'm going to move that 3x over. And then I'm going to divide both sides by x. So that ultimately is what the inverse function should look like. Or equivalent, depends on how I actually put the answer choices. So another way to write the same thing is I could have written it as 1 over x minus 3. And you should recognize that that's really the same thing. So hopefully you're good enough with algebra to, whether I put the answer in either of these formats, you should recognize that they're saying the same thing. So, oh yeah, I didn't even remember. It's been so long. I didn't remember that I did put this format. So this format here fits. And that's question 2. Question 3. Okay, so there are a bunch of pictures for question 3. Whenever that happens, it's actually easier for me to move it on the other screen. So give me a second here. It's easier to select multiple pictures when I have a keyboard at my disposal, which the tablet I'm writing on doesn't. Okay. So I posted all those pictures here. All right. Which of the following shows the graph of the inverse, a graph and its inverse? You don't even know which function is which. Oh, I did tell you. The function is a solid line, and the dashed line is supposed to be the graph of the inverse function. But actually, it doesn't even matter. Like if one graph is, I could have said the real function was the dashed line, and the solid line was the inverse. It wouldn't actually matter. The point is, you're supposed to recognize the graphs. You should be able to obtain you can obtain one graph from the other by reflecting in the line y equals x. So that's the main strategy for graphically identifying inverse functions. So essentially what you're going to do is you're going to come up with the line y equals x, and you're going to ask yourself, if I were to reflect the black line into this line, what would it look like? You'll notice here that it should look like that, which is not what the dashed line looks like. So this would be f inverse here. So that's not the option. Similarly here, I would draw the line y equals x, and I would notice, well, if this were to be reflected, the inverse should look something like this. Right? So f inverse should be there, so that's not the one. If I sketch the line y equals x, the inverse would be like a reflection in that line. So f inverse should be there, which is not the red line. If I draw here the line y equals x, then if I flip this in a mirror over that, yeah, that actually makes sense. So this is the option here. So it takes a long time for me to explain it, but if you know what to look for, you would be able to do this problem and problem one in a few seconds, 5–10 seconds. But I'm explaining to you guys what I'm thinking. But all the picture problems in this quiz, it should be something that honestly, if you can't do it in like 10 seconds, it's indicating that there's a concept you're missing. So make sure. This is something that students are often not aware of as well. Let me again go off on a mini rant here. Sometimes when you're getting problems correct, even if you're getting them correct, the fact that you might be taking a longer time to get them correct than you should can indicate that something is off that you're not realizing. And so I can tell you for sure, graphing problems, if you don't have them in a few seconds, it means even if you're getting the right answer, if you're taking 2, 3, 5 minutes to get the right answer, it means something is wrong, right? It's not as wrong as it could be, but it's still bad. It means there's probably some sort of tricky scenario that I could put on an exam that's going to throw you for a loop. So be aware of how long you take to solve each problem type. For the graphing problem types, shouldn't take you long at all. Which of the following has an inverse? So we know that inverse would mean it can pass the horizontal line test. So this guy here, this guy is a parabola, so fails the horizontal line test. This guy here is going to be an absolute value function, so it's a v. It would fail the horizontal line test. This guy here, at first you don't know what it would look like. I'll talk about this in a little bit. But if you skip ahead to this guy, you realize that that's just a shifted cubic, right? So that's guy like that. And this would pass the horizontal line test. So here, these do not pass the horizontal line test because it touches it in 2 spots. But this one, I know is the answer because it's a multiple choice and it's one of the possibilities, which means you can ignore H by process of elimination. However, that being said, what I would have done in this scenario, if you wanted to convince yourself, is to just realize that your x cannot be -1 and your x cannot be 1. And then you'd also realize that this is really 1 over x squared minus 1. So there's kind of a quadratic nature in it. You can realize that if I plug in x equals 2 or x equals -2, we'd get the same. So that kind of tells you that this graph is going to look something like this in this region. And it would look something like that. Because the right and left side have to be symmetric. And you can actually guess this by plugging in values. Notice here that, would that be correct? Let me make sure. If I plug in x equals 0, I get a negative number. So the middle part is underneath, right? Whereas if I plug in anything x larger, I would get something greater than 0. So it should be above. So the graph would actually look like that. And I do talk a little bit in class about how you would actually go about those graphs. But here, if you were confused by h, I would just keep going. You'd realize that I is actually one that would work. So you don't even have to know technically what h looks like in this problem to get the right answer. When a polynomial is divided by x minus 5, the quotient is blah, and the remainder is 4. Which of the following statements is true? X minus 4 is a factor of p. Well, that doesn't even make any sense because x minus 4 wasn't even brought up. So forget that. We're dividing by x minus 5. So I don't think it would say anything about x plus 5 either. So x minus 5 is a factor of p. And the answer is no, that's not true because remainder would be 0 in this case. X minus 5 is not a factor of p, and 5 is not a root of p. This is correct. We know that whenever something is a factor of another by the factor theorem, the remainder should be 0. So that's a concept question there. You didn't have to calculate anything. Similarly here, this one has a bunch of numbers, but it's also a concept question, which again, I think this came up in only one of the last 2 classes. I don't remember if it was with you guys or the other class. But use the rational roots theorem. If rational roots exist, they must be of the form what? And remember, the form takes place to be plus or minus factors of constant term divided by factors or factor of leading coefficient.
Professor,
So,
quick question about the question above, just about the wording of root. If something's not a factor, does that mean it's not a root? Because I thought if you take like the constant, so like 5 over like a factor of 3.
oh no, the rule is the following. The rule is if x minus a is a factor, then x equals a is a root. And you know something is a factor, it means the remainder is 0 when you divide.
Okay, I get that. Thank you.
So here I noticed that the remainder was not 0, which means it's not a factor, which automatically means that the number beside the x, if I write it as x minus a number, that number is not a root.
Thank you.
Yeah, okay, no problem. So now the main strategy here is it has to look like a factor of the constant term over the factor of the leading coefficient. So once you see this a polynomial and I ask a question like this, you're going to identify 2 things. You're going to look at this guy, the constant term, and look at the factors. It's only 1 and 7 because it's a prime number. Then you look at this guy and you look at all the factors. It can be 1 or 3 or 5 or 15, right? Those would be the guys that would show up in the prime factorization. And so the idea is I want all possible combinations of this guy. So factors of the constant term is this guy. And then the factors of the leading coefficient is that guy. So I want all possible combinations of there's either a 1 or a 7 on top. And there's either a 1, a 3, a 5, or a 15 on the bottom. And once I realize that is what I'm looking for, the answer should be at that point obvious. It looks like this. So this is 1 over 1, 7 over 1, 1 over 3, 7 over 3, 1 over 5, 7 over 5, 1 over 15, 7 over 15. So another conceptual question. Takes a long time for me to explain it, but if you know what to look for, again, this is something you should be able to do in a few seconds. Question 7 has a lot of pictures again, so let me move it on the other screen. Which is the graph of the function? So we're splitting up. So the important thing is to realize that this is what you're doing. So you want to know, what does this thing look like on the left? This is where x is less than -1 versus the right, x is greater than or equal to -1. And on the left, I realize that it's a quadratic, it's just y equals x squared. You don't always have to do this, but especially if you're not comfortable with this in the first place, what I would do is I would draw each graph separately and then cut it off. So I would first look, well, I know what y equals x squared looks like. It looks like this. And I know what y equals 2 looks like. It looks like that. And I want one of these on the left, which means I want to pick the part here. And I only want the part on the left, which means I would ignore this. And for this one, I want the part on the right of that point, so I would ignore that. And then you kind of put those two pieces together for the main graph. So it's going to look like something like a quadratic like that. And then it's going to be a straight line like that. And to figure out where this guy is going to be, you would plug in the x value into each function. So if I plug in x equals, this should actually not be. So if I plug in x equals -1, so x squared is equal to 1 when x equals -1. So this part here is at 1. And then if I look at 2, well, that equals 2 when x equals -1. So the other one should start at 2. So I know that's the graph I'm looking for. And that looks like the first one, actually. Yeah, so they don't connect because when you plug in x equals -1, to remember to figure out the endpoints, you actually plug in the x value. So yeah, it's not going to be that. Not going to be that because the quadratic is on the right when it should be on the left. Not going to be that because 2 is not a vertical line. Yeah, so again, this is something where this one's a little bit harder because you have to construct the graph separately, but it's also possible for a lot of students with a lot of practice to be able to get to this stage. So I would say you do want to practice enough of these to get to the stage where you don't need to draw 2 separate graphs, but you can actually start by drawing on one pair of axes all at once. And that's when you know, when it comes to this problem, I'm in the A or A plus category, right? If you're the person who has to do this, you're in the B plus category, right? Which means you can get this problem completely correct, provided that I didn't make each graph too complicated. But if you're here, it's okay if you want to move on to another topic. But if you want to be like, I'm an A student, you want to get to the level where you can just immediately go here. So. Which of the following statements are true? So basically, this is relating logs and ln's, e's and ln's. But there's a general concept here. In general, this is really testing you about the first rule of logs. If we write log to the base a of b equals c, it's the same as saying a raised to the c equals b. And remember, log to the base e is ln. So this means if I write ln of b equals c, it's the same as me saying e to the c equals b. And by looking at it that way, using both of these, I can figure it out. So here, the first one should say e to the 2.35 should give me 10. Okay, so that's true. That's not true. Then moving on to the second one, I'm just literally matching these up with the rules I just wrote right there. Radical 2, the log equation says, so I'm looking here right now. This should tell me that radical 2 raised to the 5.61 should give me 7, which is not what that says. This one said if I take 10 raised to 1.23, I should get 17, and that's correct. So again, conceptual question. That one shouldn't take you too long. This one might take a little bit longer. But here, I know that ln of a over b should give me ln of a minus ln of b, which is not what this one says. So forget about it. Forget about it. Okay, here, I also know that ln of the radical of something should be 1/2 ln of that thing. And so, yeah, this actually works. Here, this actually works. And so here, mostly the rules I'm using is this. And if I have ln of a product, it should be ln of the sum of the logs. As well as every time I see like a radical, I can rewrite it as a power and move the power down in front. So if I see a square root, I can also rewrite that as a 1/2 in front of the ln. If I see a cube root, I can rewrite that as 1/3 in front of the ln. So moving on to the last one here, I can think of that as 1/2 ln of x plus 1 minus, right, so this is not correct. And the reason it's not correct is because there are parentheses missing. So again, I kind of breezed through questions 8 and 9 very quickly, but really, if that went too quick for you, what it means is you haven't memorized the rules yet. So once you have the rules memorized and you kind of just know it like second nature, 8 and 9 would actually be no problem. If you're still kind of having trouble following what I just did, it means you need to go and memorize those 10 rules better. Okay, so that's what that means. So this is not a technique or a concept issue. It's did you memorize the rules issue? Okay. So this one actually requires some calculation. So let's actually do that. So if I have e to the 2 ln of the square root of x cubed, what I can think of this as, well, that's e to the, there are multiple ways to do this, by the way. So it's x cubed squared. So that's just e to the ln of x cubed. And I know that when e and ln are right beside each other, they cancel. So that's just x cubed. You should note here, x must be positive. because of the ln, right? Because you need a positive number to work in the ln. Why is that going to matter? This is because we know that the square root of something squared, we have to worry about the fact that x cubed can be negative or positive, and so we have to wonder about absolute values and things of that sort. So absolute value is not necessary. Or anything like that, right? So if you're squaring a radical or taking a radical of a square, in this case, it shouldn't matter because for it to even work in the first place, it should be positive. So your absolute value of x would be equal to x if x is positive. So you don't have to worry about any of those issues. So here I can just apply the rules directly, and x cubed is the winner. Consider this polynomial. Answer the following. Note that p of minus 2 equals 0. Which of the following statements can we conclude from this fact? X minus 2 is a factor. No. We can conclude x plus 2 is a factor, right? Because this means this is saying that x minus a minus 2 is a factor. This implies that x equals minus 2 is a root. So I already spoke about this concept earlier. So we can conclude that. Using the rational roots theorem and long division, fully factor that guy. Fully factor p. So p is x cubed plus 5x squared plus 5x minus 2. Okay. So it's probably very tempting here to try factor by grouping or something like that. You'd realize that it won't work though. And so, yeah, all right. So rational roots theorem tells us possible rational roots are, it could be plus or minus 1, or it could be plus or minus 2. And so what I would do is I would plug in each of these guys, but we know p of minus 2 equals 0. That was even mentioned in the problem, so I don't have to actually go through the checking phase. I know that minus 2 is going to work. So this means that x minus a minus 2, which I can write as x plus 2, is a factor. So I know when I factor this, there should be an x plus 2 somewhere. So automatically by process of elimination, I'm sorry, I minimized something. Automatically by process of elimination, it cannot be this and it cannot be that, because I know that x plus 2 should be a factor. So it's not these. In which case, you can actually if you're really good with the arithmetic, you can actually multiply out the others and see if you get the answer. But let's do a little bit more efficient. It does say long division, so I would actually continue with the long division. So now long division would mean I'm going to take the x plus 2 and I'm going to divide it into the x cubed plus 5x squared plus 5x minus 2. And I did long division with one of the classes last time. I don't remember if it was these guys, but let's actually go into it. X into x cubed goes x squared x squared times everyone, I get x cubed plus 2x squared. Then I would have 3x squared. Then I would say x into 3x squared goes 3x. 3x times everyone, I get 3x squared plus 2x. And again, here, I would get 5 minus 2, so that's 3x again. And then I say, sorry, 3 times c, that's 6. So here I would get minus x. X into that goes minus 1, minus x, minus 2. So that gets 0. So here I know I probably did things correct because I should get 0. If I didn't get 0, that would definitely be a red flag. And so what this means is that P of x equals x plus 2 times x squared plus 3x minus 1. Then I would check if this factors further, and I would notice it does not factor further. Because I would need two numbers that when I multiply, I get a minus 1. When I add them, I get a positive 3. No such numbers. No such real numbers anyway. And so that should be my final answer. And that looks like the choice here. Okay, a lot of diagram problems. So this is again one where first I'm going to move it on the other screen. Second, this one actually shouldn't take you very long. Okay, 1-to-1. We basically want to see if it passes the horizontal line test. So fails. Works. Fails. Works. Fails. Works. Onto. This one is actually very important that we recognize what the codomain is, because the definition of onto takes into consideration the codomain. So we said the codomain is all real numbers, which means I want every possible y value to be an output. And because this goes up forever, all positive y values and all negative y values are attained, so this works. This one does not work. For example, there is no point like where y equals 1. There's no point along this line. Also, if I pick a point up here, there's no point along that line. This one goes up forever, goes down forever, and no gaps in between. That works. This one, if I were to pick a negative y value, there's no point on that line. This one, if I were to pick a negative value, there's no point on that line. So again, should be a few seconds. The graph of y equals e to the x. So the graph looks like this. And again, knowing the codomain is very important for the onto problem. Is the graph one-to-one? Yeah, it passes the horizontal line test. Is the graph onto? No. It's onto the positive real numbers, which when we're finding inverse functions, we restrict the codomain to be that, which is why we know we can find an inverse. But in general, if I think of the codomain as all real numbers, it's not onto. The graph of ln looks like that. Notice that all y values are attained because it goes up forever and down forever, so it's definitely onto. Is it one-to-one? It does pass the horizontal line test. So this part is only true if codomain is positive real numbers, which in class we did assume. We mentioned that an exponential function always returns. When the base is positive, it always returns positive numbers. And that's sort of it. So I think we finished this in about as much time as I gave you for the quiz, and that's with me rambling and going off on tangents. So I think the timing was fair there. But I will continue to work through the bonus. At this point, if you have to leave, you can leave, but I'm going to take a few more minutes to finish these bonus problems. So if you can stick around, I would suggest you stick around. But at this point, if you have to have another class or something, you can leave. Solve the equation. So what I would probably do here, so if I have 1/3 ln of 8x cubed, 2.5. One thing I could do here is I could multiply both sides by 3. That'd be 7.5. This means I can raise both sides to the e. E to the 7.5 would be equal to 8x cubed. And so this means that e to the 7.5 over 8 equals x cubed. And this means that x would be e to the 7.5 over 8 to the 1/3. That would give me e to the 2.5 back and 2. This one right here. There were many ways that you could go about actually solving that. But that's one way. Solve this equation. So standard strategy is if you have multiple logarithms, you can bring them all to one side. However, knowing that log is 1-to-1, you have other strategies here. You can also use the strategy, the fact that we have a log on both sides, to raise both sides to the exponential 5 to kill the logs. So essentially, if you have log of something equal log of something else, the somethings must be equal. This is a direct consequence of log being 1-to-1, right? So if the outputs are the same, the inputs must be the same. This ends up meaning that we have to solve a quadratic equation. Let's hope these guys factor. Looks like a 5 and a 2 can probably work. Make a -5 plus 2. So my x equals 5 or my x equals -2. X cannot be -2. I would reject this because that would make inside here negative. If my x equals 5, I would have 25 minus 10 on the right side, which is a 15, and I would also have 3x would also be 15. So this x equals 5 actually works. So that would be that. Where are the others? One last bonus. Solving the exponential equation. So one of the main concepts here is that you can use exponentials to cancel logs. We're going to use the opposite idea here. We're going to use logs to cancel the exponential. So here, if I have 3e to the 4x minus 5 equals 24, first thing is I want to get the exponential by itself on one side, so I would actually divide both sides by 3. Then what I would do is I would ln both sides. Because that allows me to kill the e on this side. So that means that 4x minus 5 equals ln of 8. And so what I can do now is say 4x is equal to 5 plus ln 8. And so my x is going to be 5 plus ln 8 all over 4. 5 plus ln 8 all over 4. That's this one. So that is everything. So hopefully that wasn't so bad. I think we still finished in a reasonable time, even though we had a lot of other things going on today. So pretty convinced that the timing was fair for this quiz. Even with me explaining everything that you wouldn't have to explain and rambling off topic on a few spots, we still finished in within the time that I would have given you for the quiz. So that's nice, including the bonus. So yeah, stick with your study groups. Set up a time where you guys can meet regularly, keep each other accountable, and be sure to fill out the doodle poll for tomorrow's session. And for now, since we are running about 10 minutes over time, I will actually stop there. So as always, I'll post the video and the notes. Probably don't have to watch the other video for today's class because I'm going through the same material, so it's probably going to be very, very similar unless someone asks a question where I elaborate. So you can probably just look at the notes for the other class, but for now, I think that's it. So have a good day, everyone. Good luck moving into finals week. I will keep you updated on any other activities that I think I'm going to institute in order to help you guys during finals week. And for now, I will say that's it. I will see you guys in the next one. Ciao.